Hey guys, how's it going? Welcome to day 4 geometry. First off, great job this week figuring out how to watch these videos, submit your assignments. You guys have been doing a really awesome job of getting your work done, getting it done on time. Let's continue that this week. I'm really proud of you guys, how you've adapted to this. Today we're going to be looking at what if two secant lines intersect inside of a circle? Right? And a reminder, a secant line is a line that touches a circle how many times? Well, a secant line touches a circle twice. So we have two secant lines intersecting inside of a circle. And we already have that with central angles, but now what if it's not at the center? So let's take a look at an example here. So in this picture here, my goal is to figure out that angle x degrees in there. Okay. So, well, let's think about what we know, right? We might say, oh, it just equals 130. But that's only for central angles, okay? And this is not a central angle. We can see the center is up here. This angle is not a central angle, so it doesn't equal the bend. You might say, oh, I'll just do 130 divided by 2. Well, that only works for inscribed angles. Inscribed angles have vertex on the circle. So I can't do 130 over 2. But what's going to happen is there's going to be a relationship between this angle here with the bend above it and below it. Okay, and what we're going to do is discover that relationship today. And again, remember I told you in math, we always go back to things that we know before. So let's take a look at how we do this. If I wanted to figure this out, the measure of x degrees here, I can do this by using things I already know. And what I'm going to use that I already know is inscribed angles. So watch what I'm going to do. I'm going to connect points I'm going to connect points B and A real quick. If I connect points B and A, then what I make is this now is an inscribed angle because its vertex is on the circle. And we can see the arc that is intercepted by that is this arc up here, arc AD, which is a value of 130. Well, we know that angle equals bend divided by 2. So right away, I know this angle is half of 130. Half of 130 is 65. So I'm going to put 65 right here. Okay. But by connecting B and A, I didn't just make one inscribed angle, I actually made two inscribed angles. If you take a look at angle BAC, that's an inscribed angle as well. And if we can follow this inscribed angle, we can see it intercepts this arc of 30 degrees, which means this angle right here, angle BAC, has to be half of 30. Half of 30 is 15. That angle right in there is 15 degrees. Now let's think about how we can figure out how that helps us get x. Well, if you notice, triangle AB, right, we now know two of the angles. Now, one thing students might do here is they might say, okay, 65 plus 15, what is that? Well, that is 65 plus 10 is 75, plus another 5 is 80. So they might say, okay, these two angles add to 80, which means this angle right here must be 100. And then they can say these two must add to 180, so x is going to be 80. But we can be even quicker and smarter than that. Okay, think back to when we did triangles way at the beginning of the year. Remember when we said exterior angle equals non-adjacent plus non-adjacent, right? We'd say y plus z has to equal x. Well, that's what we have right here in this triangle with an exterior angle. So this x right here has to equal 15 plus 65 which equals 80. So we get this angle here to be 80 degrees. My question is, how does that 80, how can we get that answer just looking at the two that we have? Okay. Well, if you think about it, where did this 80 come from? Well, it was half of 130 plus half of 30. Okay, so what we're going to get here is that this angle is the sum of these two. 130 plus 30 is 160. 160 divided by 2 is 80. So I like to think of this as angle equals bend plus bend over 2. If we solve it that way, right, what was our angle? Well, our angle was x. We didn't know what the angle was at the time. What were my two bends? Well, it was 130 plus 30 divided by 2. 130 plus 30 is 160. And 160 divided by 2 is 80 degrees. So that's how we can get x to be 80 faster. Now again, it happened to work in this numerical example. I just want to prove it. Remember, when we prove things, we have to use letters. Well, let's prove it the same way we did it. And watch this. Again, I can use the other side as well. So I'm going to connect these 2 points. I know that this angle right here, I know that that's an inscribed angle, and I know its value has to be whatever x is divided by 2. This inscribed angle up here intercepts this arc y. So this angle has to be y over 2. If I use the exterior angle theorem, that tells me that z equals x over 2 plus y over 2. Right? This exterior angle has to equal the sum of the two non-adjacents. Right? And just to combine this then, these two already have the same denominator. So I can say z equals x plus y over 2. Again, the z represents the angle. The x and the y are the bends. So we get it down to a nice simple formula of angle equals bend plus bend over 2. So again, I want you to circle that. Angle equals bend plus bend over 2. This is our formula. I want you to remember it like this so you know where to put things. You'll see in the examples here. So this is for a secant secant interior. So let's take a look. Let me show you some examples here. By the way, they don't have to be secant lines. These would be chords. But what we're looking for is an intersection that occurs inside of the circle, but not at the center. So let's just do a couple examples together. Let's say that this is 122 degrees, and let's say this down here is, I don't know, let's say 48 degrees. All for this angle right here. Well, again, I'm going to follow. I see that that's an interior intersection. So I'm going to say angle equals bend plus bend over 2. What's my angle here? Well, the angle is, I don't have a number for it. It's marked as x. I do angle equals bend plus bend over 2. Oh, 122 plus 48 makes 170. And 170 divided by 2 means that x must be equal to 85. And I'm done. Let me show you another one. Now, right away, you should see something is different about this problem. Okay? Now, one mistake that students make is they say x equals 100 plus 70 over 2. And that would not be correct. Okay? Because it has to follow angle equals bend plus bend over 2. So when I set this up, it's going to be set up differently. I always start angle equals. Well, my angle is 70. So I'm going to say 70 equals bend plus bend over 2. Notice the difference here. In this one, x was already by itself. In this one, x is most definitely not by itself. So I have to solve it a little bit differently. My question for you is, how do I get x alone? Well, x has got a couple things going on here, but I want to first get rid of this fraction. So I'm going to multiply both sides by 2. And I get 2 times 70 is 140 equals 100 plus x. Now I can solve for x by simply subtracting 100 from both sides. And I get x equals 40. So I get x equals 40 in here. You can always go back and check to make sure it's right, because bend 100 plus 40 is 140. 140 divided by 2 makes 70. Just be aware that these two problems have the same equation, but here x represented the angle, right? So x was right here. Here x represented a bend, so x was up here. Okay. Let's try another one. Okay. So again, I have this set up here. I know this bend and this bend. So what I'm going to say is, okay, here's my x. This is my interior angle. So I'm going to say this angle equals bend plus bend divided by 2. I have to solve for x here first because I don't know this bend or this bend. So I have to get x first here, and then I'll figure out how to get y after. Again, I start with angle equals. What's my angle in this case? My angle is x. So I got to do bend plus bend over 2. 50 plus 70 is 120. 120 divided by 2 is 60. So I get x equals 60. Well, if x is 60 degrees, how can I find y? Well, once again, these two angles here, those two angles, right? The angle that's x and the angle that's y, these two have to add to 180. Therefore, if x plus y equals 180 and x is 60, 180 minus 60 is 120 for y. Let me show you one more example and then we'll be done. So let's say that this is 55 degrees, and let's say this is 90 degrees down here. Okay, so if I want to solve this thing, I have to set it up as angle equals bend plus bend over 2. And I'm doing that because it's an interior intersection. Okay. I didn't draw this one very well to scale, I realize now, but that's okay. So I'm going to start with 55 equals bend plus bend over 2. Now to solve this thing, to get x alone, I'm going to multiply both sides by 2. I'm going to get 110 equals x plus 90. And solving for x, I'm just going to subtract 90 from both sides. And I get x equals 110 minus 90 is 20. And again, I can go back to check my work and make sure 20 plus 90 is 110. 110 divided by 2 is 55. Okay, that's it for day 4. And go ahead and do the homework, check it against the key, and submit it. Talk to you guys later. Bye.